Chapter 7, Section 2, the natural logarithmic function. In this section, what we're going to do is we're going to do derivatives and antiderivatives with the natural logs. And these are some of the log laws that we talked about in pre-cal. For some of you, it may have been a while, so we'll review these. I need you to understand that the natural log of x is equal to log base e, and remember e is just a constant, of x. And so here are some log laws that we talked about again in pre-cal. Remember that if you have a natural log of a product, you can separate your natural logs and change that to addition of exponentials. So again, here when you take the natural log of a quotient, you can break them up and it's top minus bottom, just like your exponent rules. And then this is the last one. If you're taking the natural log of a power, what can happen is you can take your power and move it over as a coefficient, and so now you have r times the natural log of p. Okay, so the actual calculus part of it is the first thing we're going to do is take derivatives of the natural log. And so I need you to remember the derivative with respect to x of natural log of x is 1 over x. But what I'd like you to remember is this one. And the reason being is because it includes the first one, but it also includes all of them. So the derivative with respect of x of natural log of u, and that's going to be basically anything that does not have a derivative of 1, which is what happens up here. The derivative of natural log of u is equal to 1 over u times the derivative of u. 1 over u times the derivative of u. And then here, if you have something in absolute value, it's kind of like an embedded function as well. This just says that the derivative of the natural log of an embedded function, or the absolute value of an embedded function, is equal to 1 over u times the derivative of u. So again, this is the main one that we need to remember. The derivative of the natural log of any function is 1 over that function times the derivative of the function. So let's look at this one. We're going to find the derivative of the natural log of the cube root of 6x plus 7. Now, we know that this can be the natural log of 6x plus 7 raised to the 1/3. And we can also say that using our log laws, we can move that 1/3 up to the front and have 1/3 natural log of 6x plus 7. And so that's what I'm going to take the derivative of. Now we know with a constant we can move that constant out front, and so, or we can just ignore that constant and say 1/3 times your constant times the derivative of the natural log of 6x plus 7 is going to be 1 over 6x plus 7 times the derivative of 6x plus 7, which is just going to be 6. And then from here it's just basic algebra dealing with our fractions. We know that the 3 will cancel out with the 6 and go 2 times. And so when we multiply all this together, we'll get 2 over 6x plus 7. And again, when you do that, just remember that you cannot cancel the 2 and the 6 because the bottom is a group. So that the only way you can cancel a group is when you have another group. Now I do want to show you something else. What if you forget to go from here to here? Well, if you forget to move your 1/3 down in front and go this way, that's okay, because we can also say, use our basic derivative rule, that the derivative of the natural log of u is 1 over u times the derivative of u, which you know that we're going to use the chain rule, so we're going to have 1/3 times 6x plus 7, and then we're going to lessen 1/3 by 1, so that's going to be to the negative 2/3 times the derivative of what's inside, which is going to be 6. And so we're going to have let's just clean all this up, I guess, so you can see that this is a lot more work, but it is doable. So what's going to happen is on top, you're just going to have that 2. And on bottom, you're going to have 6x plus 7 to the 1/3. times 6x plus 7 to the 2/3. And when you add those together, when you multiply powers with like bases, you add those exponents, so you have 2 over 6x plus 7 to the 3/3, which is going to be 1, of course, and so you see you get the same answer. So you can tell that the power rule is going to help here. If you move your power over to the front and then take the derivative of it from there. To me, that's easier than using the chain rule, but again, if you forget to use that power rule and move the exponent over to the front, then you are going to have to use the chain rule. Alright, so let's look at this one. And so, again, you can use the product rule on this. You can do 1 over 2x minus 3 to the 3rd power times 4x plus 1 to the 4th power, and then times the derivative of that, which is going to be your product rule plus chain rule. So, yes, you can do that if you want to. But to me, again, it's easier to use log laws than using the product rule and the chain rule. So the first thing I'm going to do, I think, is I'm going to fix this. And so I'm going to do the natural log of 2x minus 3 to the 3rd power plus the natural log of 4x plus 1 to the 4th power. And then I'm going to use that power rule, so I'm going to have 3 natural log of 2x minus 3 plus 4 times the natural log of 4x plus 1. And so now I'm ready to do the derivative. And so we're going to move that 3 out front times the derivative of the natural log of 2x minus 3 is going to be 1 over 2x minus 3 times the derivative of 2x minus 3, which is going to be 2, plus 4 times the derivative of the natural log of 4x plus 1 is going to be 1 over 4x plus 1 times the derivative of 4x plus 1, which is essentially going to be 4. Okay, so from here we're going to have 6 over 2x minus 3 plus 16 over 4x plus 1. And you know the only way to put together, because we need one fraction here, and the only way to put together a fraction through addition is to find a common denominator. Well, the common denominator is going to be 2x minus 3 times 4x plus 1, and that is your algebra. That's going back to Math 100 or Algebra 1, whatever you want to remember. Okay, and so we need to multiply the first fraction, the numerator, by that 4x plus 1, and when we do that we're going to get 24x plus 6. And we need to multiply the 16 times the 2x minus 3, which is going to give us 32x minus 48. And so now we're ready to put these two fractions together by adding the numerators. And so when we do that, we're going to get 56x minus 42 all over the common denominator. And so this time, what's going to happen is we're going to take the derivative of the natural log. Well, the derivative of the natural log of u is going to be 1 over u. And u, your argument basically, is cotangent x squared. Times, so 1 over u times the derivative of u. So the derivative of cotangent x squared is going to be negative cosecant squared, and then your argument, x squared, times the derivative of your argument, which is going to be 2x. Alright, and so you need to understand that all of this is on top. And so to clean this up, we're going to have, and I'm going to move the coefficient of 2x up to the front here, and so I'm going to have negative 2x cosecant squared x squared over cotangent x squared. And then from there, because these two are, they have like arguments, you could see if this is going to cancel, any of this is going to cancel out. This is going to be 1 over sine, and this is going to be cosine over sine, so some things might cancel out there. You can play around with it and see, just to see if you can simplify it.